All right, in this video, we are going to talk about finding the domain and range of functions. So when you're given a function that's written in function notation, the domain of the function is not entirely obvious. So when you're given a function like that, it's pretty much up to you to determine the domain of the function. If you remember back when we talked about writing relations and functions as sets of ordered pairs, it was really easy to find the domain because you just went through to the ordered pairs and you picked out, you know, the you picked out the first numbers and that was it. So when you're given a function, right, then in the function notation, you've got to figure it out, right? It's not, the ordered pairs aren't entirely obvious, okay? And so the convention, right, the rule is that when you're given a function in function notation, the domain is the set of all real numbers for which the value of the function is a real number, okay? And so that is fairly vague if you have not experienced what that means before. But basically, how I like to think about it is that when I'm given a function like that, what I need to do is to basically go through and check that function to see if there are some problems that might happen. There might be some numbers that when you plug the number into the function, the output is not going to be a legitimate number. Okay, and so you've got to know what problems to look for, and we're going to keep it really simple to start off with. Okay, and we're only going to check for two types of problems. Okay, now as you move forward in math and in your math courses, you will encounter other situations that you have to look for. So as you move forward, you'll have like a list of things that you need to be looking for. But for the time being, right, in our class, we're only going to have two, and then we'll probably add another one at the end of the class, towards the end. Okay? All right, so I'm going to talk now about what those two problems are that we're going to start off with. And the first one is a division by zero problem. So you might have a function and it might have a fraction in the bottom of, and in the bottom of the fraction, rather, there is going to be a variable. Okay? And that's going to cause an issue. So for instance, if I have something like this, f of x equals 1 over x minus 2, right? If I evaluate the function at 2, if I plug in a 2, then I'm going to get 1 over 0. And you cannot divide by 0, right? There's no meaningful way to do this. So that is a problem, okay? That is an input. 2 is a legitimate number, but when I plug it into the function, I don't get a legitimate number output, all right? And there's no way to fix that, right? So what we would say is that 2 is not in the domain. In other words, don't plug 2 into this function because when you do, something bad's going to happen, essentially. All right? So that is the division by zero problem. All right, so that is when you're asked, hey, what is the domain of this function? That's at the top of the list that you're going to check. You're going to ask yourself, hey, does this function have a fraction with variables in the bottom part? If it does, right, then what you want to do is to set the bottom part equal to 0 and solve that out. You're going to throw out any complex number solutions. Those are solutions with I in them. We haven't talked about that at all yet. So you shouldn't run into any of those problems. I'm just throwing this step in here for completeness sake for our class. Okay. So you set the bottom part equal to 0 and solve, and you'll potentially get some solutions, right? So any solutions that you have that are real numbers, those numbers are the numbers that are not in the domain, okay? So it's everything, all the real numbers besides those ones that you have, okay? All right, let's take a look at some examples here. All right, so you're given this, actually that's the one that I just did, but that's okay. All right, so you're given this function g of x equals 1 over x minus 2. Oh. g of x equals 1 over x minus 2. And you're asked to find the domain. All right, so question number 1 at the top of the list, right? The first thing that you need to check is, okay, does this function have any fractions with variables in the bottom part? And the answer here is a big yes. So what you want to do is set the bottom part equal to 0 and solve out that equation, okay? So solving that out, I get x equals 2. All right, so common question that I get a lot is, well, what about the top? You don't do anything to the top? And the answer is not if you're finding the domain, right? So don't worry about the top, right? It's really the bottom part that's going to give an issue. All right, now there may be some further complications, but we'll kind of talk about those later, okay? All right, so now, writing the domain, right? In just regular words, it would be all real numbers except 2. Right? Because all the solutions, right, that you get here, other than complex numbers, right, you're going to throw those out of the domain. So that would be the domain in words. It's everything but these solutions. In interval notation, right, how you would write all real numbers except for 2 is like so. Oops, not negative 2, positive 2. So the interval from negative infinity to 2, not including 2, that's all the numbers less than 2. Right, and then 2 to infinity, that's all the numbers that are greater than 2. And so that would be the answer, right? This is the domain, right, of that function. A lot of times you'll see me write the domain as domain of f like this. Okay, so I'll write domain of f equals this set here. You don't have to worry about that, just you can write it like this on the test or quiz, okay? All right, let's take a look at another example. So I want to find the domain of this rational function, right? F of x equals x squared over x squared plus 9x minus 10. All right, so I want to find the domain. So I ask myself, hey, are there any fractions in here with variables in the bottom part? And the answer is absolutely there are, right? And so what I would do is to set the bottom part equal to 0 and solve that out. All right, that is a quadratic equation. I can factor it. I would need two numbers that multiply to give me negative 10 and that add up to give me 9. So that would be a positive 10 and a negative 1. Okay, so I have 0 on the right side, the left side is completely factored. Then I would set each of those factors equal to 0 and solve those out. So I get x equals 1. Over here I get x equals negative 10. All right, so the domain would be all real numbers except negative 10 and 1, right? So in interval notation, that would be from negative infinity to, that looks terrible, negative infinity to negative 10, union the piece between negative 10 and positive 1, and the piece to the right of positive 1. Okay. All right, and so that would be the domain of this function. All right, so next up is what I call the even root problem, right? That's the other problem that we are going to check for initially. And the question that you need to ask yourself is, does the function have any even roots? All right, if it does have an even root and you have a negative sign underneath that even root, that is going to come out to be a complex number, right? And in our class, what we want is for our functions to have real number inputs and real number outputs, not complex number outputs. Okay, so that's the situation. You could have a number, and let's say when you plug in, let's say f of x equals square root of x minus 5, and I plug in the number 1. Right? 1 is a real number, a perfectly legitimate number. And when I start evaluating this out, you'll see I get a negative underneath the square root sign. And when you have a negative underneath the square root sign, right, it comes out as the complex number I. And the square root of 4 is 2. So this comes out as the complex number 2I. All right, if you're not too familiar with complex numbers, then don't worry about it, because you can easily tell, right, when you run into this situation, you get a negative number underneath the radical sign. Okay, and if it's an even index root, if it's a square root or fourth root or sixth root or eighth root, then that's a problem. Okay, we don't want this. We don't want the outputs of our functions to have the complex number I in them. We want them to be real numbers. Okay, so that is a situation we'd like to avoid. Right? We have a perfectly fine real number. When we plug it in, we get this complex number. It's not like there's really anything wrong with these complex numbers. They're perfectly fine numbers, right? They're used a lot in applications in electrical engineering and things like that. But in our class, we don't want to talk about these yet. We'll save that for if you're later on, if you become an electrical engineer or something like that, well then, okay, you'll have to figure out how this stuff works. Okay, but for the time being, we want to avoid this situation. So that is the even root problem. All right, so if you do have an even root, what you are going to do is to take what's underneath that even root and set it greater than or equal to 0. Okay, there's going to be a little twist on that, but we'll see, and you need to solve that out. Once you solve that inequality, right, your answer from the inequality will be the domain. Again, unless you have some other complications, which we'll look at. Okay. All right, so notice that's sort of the opposite of the division by 0 problem. In the division by 0 problem, right, it tells you, hey, these numbers are not part of the domain. When we're talking about taking into account the even root problem, the solution of that inequality tells you what the domain is. It tells you, hey, these are the numbers you want to stick to. Okay? All right, let's take a look at an example. All right, so here we have the function g of x equals the square root of x minus 2. And we want to find the domain. Okay? So what we would do is take what's underneath, right, the radical sign, just what's underneath, not the radical sign itself, and set it greater than or equal to 0. And we would solve that inequality. All right? When we solve that inequality, we get x is greater than or equal to 2. And so that is the domain, right? So the domain of f written in the inequality notation would be 2 to infinity, like this. Okay? Okay. And you can see, right, if I take any number that's 2 or bigger and plug it in here, right, I'll have a bigger number minus a smaller number that will give me a positive. As soon as I take a number that's not in here, like 1, I'm going to get a negative number underneath. So when you solve that inequality, right, it's telling you, hey, use these numbers. This is the domain. Okay? All right. So I've shown you the basics, right, of the very basic division by 0 issues and the very basic even root issues. And that is good enough for a long time. The thing is in a long time in the sense of that's the very fundamentals of what you need to know. And if you have that knowledge, then you're good on the more complicated problems. But these types of problems can get complicated in a hurry depending on how complex the function is, right? The more complex the function is, the more difficult it is to find the domain, all right? So sometimes, like in this problem that we're about to do, you will see we'll have to kind of use both of those things. This function here has both problems, okay? All right, so let's run through how we would do that. So f of x equals 1 over square root of 3 minus x. And we want to find the domain of this. All right, so remember, finding the domain for right now in our class, right, given the function in function notation like this, you want to check those two problems, right? Ask yourself the question, number one, are there any fractions in here with variables in the bottom part? And the answer is yes, there is, okay? All right, and you can see I have this entire, the whole thing is a fraction, and in the bottom, right, I have got some things with a variable in there. So I do have the division by zero problem, okay? So what do you do when you have the division by zero problem? When you have the division by zero problem, right, what you do is you take the entire bottom part of the fraction and set it equal to 0, and you solve that out, okay? So let's go ahead and solve that out. So this is an equation that has a square root in it. To solve that, what I want to do is to get the square root by itself on one side of the equation, which it is. If it's not, then I will use the addition property and multiplication property to get it by itself. Once that square root is by itself on one side of the equation, then I want to square both sides. Okay? And when I square that square root, right, I just get what's underneath. Over on the right-hand side, I get 0 squared, which is just 0. And if I add x to both sides, I get x equals 3. Okay? So I have done what I'm supposed to do in the division by zero. I had a fraction with variables in the bottom. I took the bottom, I set it equal to 0, and I solved that out, and I got this solution. What is that telling me? This is telling me that 3 is not in the domain. Okay? Now, before I jump to a conclusion about what the domain is, I need to check to see, right, if that has the other problem, okay? In the previous examples that we did for the division by zero, it didn't have both problems, right? This function does have both problems, right? It has the even root problem, right? So we would need to do the work for the even root problem. All right, so I ask myself, hey, does this have any even roots in it? Does it have a square root, a fourth root, a sixth root, an eighth root, and so on and so forth? The answer is absolutely it does. There's one right here, okay? So what do I do if I have an even root, right? I take what's underneath, right, the root itself. Just what's underneath the root is 3 minus x, and I set it greater than or equal to 0, okay? And then I solve that out. Here I subtract 3 from both sides, and then divide both sides by -1. So I get x is less than or equal to +3. Okay? And if you just have the even root problem by itself, then that would be the domain, but we don't. Okay? So if you have both problems like this, then you're going to have to kind of reconcile the information that you're getting from both of those things. This, right, the fact that x is less than or equal to 3 would be telling us that the domain would be this, okay? It's saying all the numbers that are less than or equal to 3, right, are in the domain. And the thing is, right, then I also have to take this information into account as well, that's saying that 3 is not in the domain. Right, and so the action and putting those two together, right, that gives me that the domain is going to be all of these numbers except 3, right? And so we could write that as negative infinity to 3. Okay? So you can see if you have multiple problems in with your function, it's not so straightforward. You have to do the work for both of those, right? Um, and then kind of reconcile those facts with each other, right, to figure out what the domain is. So fortunately, in our class, this is going to be about as difficult as it comes, okay? But in reality, right, there's lots of wild and crazy functions out there, and it might be pretty difficult to piece together the information between those two. On this problem too, you might say, hey, couldn't I just have realized that right here that this 3 minus x was under the root and in the bottom, so I could have just put greater than 0 here, and you certainly could do that in this problem. Okay, but in general, when you have multiple problems existing in there, you're going to have to like look at each individual thing and kind of piece that information back together. Although again, we're not going to encounter that very much at all in our class. Okay, but in the future, you know, if you keep taking more and more math classes, you might. Okay. All right. Next up, find the domain. So I have f of x equals x squared minus 6x minus 1. All right, and so I'm going to run through my list. Remember, when you have the function written in function notation like this, and they want you to find the domain, then you're just going to check those two problems. So number one is the division by 0 problem. And I ask myself, okay, does this function have any fractions with variables in the bottom part? And the answer is it does not. So this problem does not have the division by 0 problem. Next, I ask myself, hey, does this function have any even roots, square roots, fourth roots, sixth roots, and so on and so forth like that? And the answer is it absolutely does not, right? So this function doesn't have either of the two problems that are on our list so far. So at this point in our class, right, we will say that the domain is all real numbers. Plug in any number you like. You're not going to run into any of those bad situations that we talked about before. In interval notation, that would be represented like this, okay? Moving forward, right, as you keep taking math classes, we'll add one more, right, the natural log or the logarithm function. When we talk about that at the end of the course, that will add another thing that you have to check for the domain. And then as you move forward in the next class, pre-calculus or calculus classes, if you have to take those, they'll add more and more things to the list of things you have to check for the domain. Okay. All right. So I think that is it on finding the domain. And here's just the summary, right? Check the division by 0 problem. Check the even root problem. Right? Write the domain in interval notation. And if the function has neither problem, the domain is minus infinity to infinity, all real numbers. That's at this point. Again, this is going to change, right? The farther you go in math, you're going to encounter more and more things to check. Okay. All right. I'm going to leave it there and then separate the other things out into their own videos.